Hello, there's exercise 12D. We've previously looked at differentiating parametric equations, so it's no surprise really that this time we're going to try to integrate parametric equations. This is the basic theory of it. The integral of y dx. Notice we get rid of dx and we replace it with this dx dt dt. And you can see that effectively those two things cancel out. We have to be a bit careful if we ever get questions with limits. Normally our limits have got to do with x, but if we switch to our variable being t's, we need to have two limits in t's. I suppose the key is finding dx by dt. If you find dx by dt, you can then rearrange it if you need to, or just play around with it. So let's have a go with it. A couple of questions. The diagram shows a part of a curve with parametric equations x equals t squared and y equals 3 minus t. So points A and B have coordinates 0 and 9. So A, I got my head around that. Find the values of the parameters at A and at B. Well, I suppose at this point here, it's 0, something, I don't know what, how high it is. But therefore I can use this equation here. I can say, well, x, which is equal to 0, because it's is equal to t squared. So I think here, t is equal to 0. And that y, this point here, I suppose this, I think this is 9, 0. So theoretically I could use either of them. Probably the one to use is this one here, because 0 equals 3 minus t. So I think for this one, t has got to equal 3. So we get two values of t. Now just notice if I'd used the x equation there, which I could have done, but there would have been two solutions, 3 or minus 3, and theoretically I wouldn't have known which one it was. So that's why I used the y value there. So I found the values of the parameter t at the points. Find the area of the curve. Well, the area of the curve is always the integral bounded by the curve and the axes. So it's this area here I want, so that in terms of the x's, it's between 0 and 9. And you always write the integral of y dx. But of course ours can't be done like that because we haven't got an equation for y in terms of x. So we're going to switch to y dx by dt dt. And we now need to find dx by dt then. So it's relatively straightforward. I'll do it up here, dx by dt. It's just 2t. So this becomes the integral of y. What was y? It was 3 minus t. Put that in the bracket. Go on with it, times it now by dx by dt, which is 2t dt. And notice I'm switching from 0 to 9 to 0 to 3 because these now have to be in t values. So I quite like that question because it forces us to remember to use the t values, not the x values. Multiply this out, I get 6t minus 2t squared. And I can easily integrate that. That gives me 6t squared over 2, which is 3t squared, minus 2/3 of t cubed. And that's in between the limits of 0 and 3. So if I think I've put 3 in, I'll get 3 times by 9, minus 2/3 of t cubed, of 27. Now I've put 0 in, I reckon I get 0 out both times, so that's 27, I reckon that's minus 18, that's 9 as an answer. Units, whatever they are. 9, yes, good. So next question. For the curve with these parametric equations, find the area below the graph. Now that looks really quite similar to the one we've just been doing. Is it very similar? X is t squared. Oh, this time it's 2t squared. Last time it was 3 minus t. This time it's t plus 2. So these really are quite similar. So let's go for it. Obviously we're going to find this integral. We're going to try and find this area here. It says this goes through 8 naught, it says here. So that looks as if it does anyway. So normally we'd find the integral from 0 to 8 of y dx. And of course we can't do that because we don't know what y is as a simple equation with x. It's parametrically defined. So first thing I'm going to do is find dx by dt. Always need to find this, and it's relatively straightforward, 4t. So over here I'm going to write the integral of y dx between 0 and 8 is the integral of y. What was y? It was t plus 2. So write that t plus 2. I'm going to times by dx dt. So remember, this is what I'm doing basically. I'm finding y dx by dt dt. So if I find dx by dt, what is dx by dt? It was 4t dt. Be a little bit careful, I need these two numbers. So what are those two numbers? So when this point here has the coordinates 0, 2. Now it's probably best to use this equation. This looks like the equation to use. This will tell me what the value of t is there. T is, well, it's 2 equals 0 plus 2. I reckon that t is 0. And here, again, I think it's best to use y equal to 0. So therefore 0 equals t plus 2, and t therefore is minus 2. And I'm saying here, that's minus. If you'd used the x equation, you could have got a plus or a minus. You wouldn't have known which one it was. I think this one's minus 2 because of this equation. I've used the one without a squared in, basically. I think it's more likely to give me the correct answers. Now I need to be a bit wary because that is a smaller number. I've got a smaller number on the top than I've got on the bottom. So one way of dealing with that is to switch it round, and I'll do that at the end. Because these are definitely, if I'm not careful, I'm going to get them wrong. Anyway, let's go for, if I multiply that out, it's the integral from 0 to minus 2 of 4t squared plus 8t dt. And if I integrate that, I get 4t cubed over 3. Plus 4t squared. 0 to minus 2. And what you'll probably find is this is a negative answer, and it's because of these being wrongly round, and I can just switch them around. So if I put minus 2 in, I get 4 lots of minus 4/3 of minus 8 plus 4 times minus 4 times 4. Minus nothing. I'll put nothing in. So let's just do that. 4 minus 32 over 3 plus 16. Oh, I've got 16/30 is positive at least, which is what I obviously wanted to do. 16/3 was the answer. I thought I was going to need loads of space there, but I didn't, it turned out. Now, this is an exam question actually. This came from a practice paper, so I'm going to try and do it. A curve is defined by parametric equations, so exactly the same as before. That and that. Now, it doesn't draw me the graph, so you've got a graphical calculator. Type this in. See if you can get what I get. So when I typed it in, I got this. That is the curve. And it says t is not equal to minus 1. Notice this is like y and x. This is not showing t value. So, but anyway, that's what I got. Show that the curve passes through the origin. Just drawing a picture probably isn't enough, so it's quite straightforward. You can see it passes through the origin, but perhaps we need to do some work. Now, the origin has a coordinates 0, 0, of course, which is the x and y values. So x is 0. So I'm just going to write 0 equals 2t over 1 plus t. Now, if I move this fraction over to the other side and multiply, that'll tell me that 2t equals 0, because anything times by 0 is 0. And therefore, at that point, the x value has t equals 0. And now, let's do the same thing on the other one. Y equal. Now, I could do exactly the same thing. Or I could, now I know that t is 0, just go 0 squared over 1 plus 0 is 0. So it looks to me as t equals 0 gives me 0, 0. So yes, I think I've shown that. It just says show. Yeah, I've done it. Find the y coordinate when x is 1. So it's slightly different. I'll do it here. I'll do it here, might as well. X is 1. Now I want the y coordinate. Well, I think I need to find the t value and then sub it in. So when x is 1, that is equal to 2t over 1 plus t. So I can ignore the x equal bit now. I've got 1 equals that. So move the 1 plus t over, it becomes a multiply, and you'd multiply by 1, so it's still 1 plus t. Move the t over, I get 1 equals t. Alright, t equals 1. So I've got the value of t, which I can now substitute into the y. Y coordinate then is y equals, it says t squared, so that's 1 squared, over 1 plus t, which is 2, which is a half. Alright, half, done. So I reckon y equals a half. So that was a couple of marks, not many marks considering. This was actually a question 14, I think it was the very last question on the exam. So it should be quite difficult. So show that the area enclosed by the curve, the x-axis and the line x equals 1. Right, they actually want this tiny little area down here. So that area is given by that. Okay then, so the area we'll always do by the integral of y dx. And of course that's in between the two values 0 and 1. 0 and 1. But we're not going to do that. We've got to use parametrics. So it's the integral of y dx by dt. So let's find dx by dt. It's what we've been doing all along. Dx. Oh, right, now I've got a little bit of a problem here, in as much that x is 2t over 1 plus t. Now, this is basically u over v. I've got to use a quotient rule. So u dash is equal to 2, and v dash equals 1. So you may recall that the quotient rule says it is v u dash minus u v dash over v squared. So what does that give me? It gives me v, which is 1 plus t, times u dash, which is 2, minus u, which is 2t, times by v dash, which is 1, all over v squared, which is 1 plus t squared. What's that give me? That gives me 1 plus 2t minus 2t. I think that just gives me, oh, it's 1 times 2. It gives me 2 over 1 plus t squared. Check the top if you don't believe me. So that's that. The other thing I need to know is these values here. So I need the x. I got the x values. It's 0 and 1. So when x is 0, I think I've already done this. When x is 0, we showed that t is 0. So I know that is 0. And when when x is 1, what did we find? When x was 1, t is 1. So t, these are the t limits. They're not the the x limits. So you might want to just make a little note we've already found earlier or something like that, because I think you'd have to justify where they came from. Anyway, so this equals then the integral of y. What was y? Y was t squared over 1 plus t. And I'm timesing by 2 over 1 plus t squared dt. Oh, I see what they've done now. Oh, between 0 and 1. And it's the integral from 0 to 1 of 2t squared over 1 plus t cubed dt. And that's what they wanted us to do. Again, I thought they'd need loads of room here. I've left a bit of room on this. But interestingly, there was a third part of this. I'm not going to do it now. There was an extra part which basically said do the integration. So if you're sat at home with nothing to do, perhaps you might want to try that. This is an integration that they wanted us to do, and it says use an appropriate substitution. So have a think about what you do. I'm guessing you're going to get rid of the 1 plus t. If it was me, I haven't even looked, I would be suggesting write u as 1 plus t. That seems appropriate to me, but we'll soon find out. I've got the answers on the next slide, so we'll show you the answers, and then perhaps we'll know if that's the right way to do it. But I would suggest you try to do it without the answers once we've established what method you're meant to use. So let's have a look at the answers. Yeah, look at that. They did use that. Just looking at it there. But that's the answer you're looking for. And in class we'll do exercise 12D. As I say, it's a relatively new topic. It never used to be on A-level maths. It is now. There might not be much examples out there, but you've got a few to do in this lesson. So best of luck.